Alright, finally we get into some of the better stuff and into derivative rules. So let's just hop on in. The derivative of a constant is equal to 0. So what I mean by constant is, let's say y is equal to 3. Now if I was going to graph y is equal to 3, I would get a horizontal line. And so again, derivative means slope. So what's the slope of a horizontal line? I'm hoping you're coming up with 0. Now this 0 that I wrote right here is the same 0 that's found over there. And so if the derivative means slope, so this question is asking what is the slope? What is the slope of a horizontal line? In this case, the slope of all horizontal lines are equal to 0. The next one, let's suppose that I have a some sort of polynomial or even a variable that's raised to a fraction, which would be like a square root. So let's say y is equal to, this case, x squared. Well, the derivative is going to be, I'm going to take my exponent, I'm going to put it in the front, and then I'm going to decrease my exponent by 1. And so I get y prime is equal to 2x to the first. And I'm not going to bother put the first there. So now let's suppose that I have the idea of a polynomial. But my polynomial has a coefficient. Let's say 3x to the 1/3. Okay, so that would be the cube root. This actually wouldn't be a polynomial. This would actually be a, one of the root functions. This actually reads y is equal to 3 to the cube root of x. And so in order to use my derivative rules, I need to put it into, I can't use this version. I have to put it in the power version so I can use my power rule. And what I'm going to do is I'm going to multiply my coefficient 3 times my power, my old power, which is 1/3, my variable, and then I'm going to decrease my 1/3 by 1. So again, I'm using the same idea of decreasing my power by 1. And so finally I get y prime is equal to 3 to the 3rd, these guys will cancel. And so I'm only left with x, and then 1/3 minus 1 is negative 2/3. And you actually can just leave it like that. You don't need to put it back into root form. Finally, if I am adding or subtracting different polynomials or different linear functions, it's if I have different pieces, different terms, I can just take the derivative of each term. So let's say I have y is equal to 3x squared plus x plus 2. I just take the derivative of each piece. And so I'm going to multiply my 2 times my 3 and get 6. And then decrease my 2 minus 1 is equal to 1. I'm going to take my coefficient for x. Well, there's just the coefficient for x is just 1. And if I decrease the exponent, 1 minus 1 is equal to 0. And so anything to the 0 power is 1. So essentially I'm having 1 times 1, which is equal to 1. And then finally, the derivative of any constant is equal to 0. So what I really have is y prime is equal to 6x plus 1. If you want to think about for a linear function, anytime that I have this x right here, a linear function, you just want to take, the slope of a linear function is just going to be the coefficient in front of the x. If you just want to just write down that number in front of the x, that's fine. Alright, let's go through several examples. They want us to find the derivative of each function using our rules, so we're going to write f prime of x is equal to, and then I'm going to use my power rule, 3 times 3 is 9, x, and then I'm going to do 3 minus 1, which is 2, plus my coefficient for my x is 2. That's the slope of a linear function, and then the slope of a constant function is 0. That's number 1. Number 2, I need to first fix it so I can put this into power notation. So I have g of x is equal to 5x to the 1/2 plus 4x. Again, I didn't take the derivative. Notice that there's no prime next to my g of x, so please don't mix your notations. My derivative now that I have everything in power form, I have an exponent instead of a square root, I can go ahead and take my derivative. So I'm going to do 5 times a half, which is 5/2 x, and then do 1/2 minus 1, which is negative 1/2, plus, and then I have 4x, so what's the slope of 4x? And that would be 4. Again, notice that my variables are not in power form, so I need to fix that. So I'm going to say x of t, again this is not the derivative, is equal to, and I only move the variables. I'm not going to move my coefficient, so I'm not moving the 2 up. Okay, I'm leaving it down there. So I'm leaving this whole thing as a fraction, and that fraction is, if you can see it, is 1/2. So I have x of t is equal to 1/2, and this will be t to the 2, so this right here is in the numerator, and the 3 is in the denominator, so it'll be 2/3 plus, and then my coefficient, since t is in the denominator, the coefficient of any number in the denominator is going to be a negative, so this will be t to the negative 1. So finally, everything is in power form, so I can go ahead and take the derivative. So x prime of t is equal to 1/2 times 2/3 t, and then 2/3 minus 1 is negative 1/3 plus negative 1 t to the negative 2. So if I wanted to simplify that, I would have x prime of t is equal to, these guys will cancel, so 1/3 t to the negative 1/3 plus negative t to the negative 2. Alright, number 4, I'm going to find a prime of t, so a prime of t is equal to, and notice everything is nicely in power form, and so I'm going to do negative 4 over 2 t to the 3rd plus 3 times 3 is 9 t squared minus 2, which is equal to negative 2 t to the 3rd plus 9 t squared minus 2. Alright, number 5, they want us to find the change in surface area over radius if my surface area is equal to 2 pi r times r plus 8. So let's go ahead and let's simplify. And so my surface area is equal to 2 pi r, and I'm going to go ahead and distribute. This will be r squared plus, let's see, 2 times 8 is 16 pi r. And so finally I can go ahead and take my derivative. So another way, instead of saying prime, I can use a derivative of the surface area with respect to the radius. That's what that DSA dr. The dependent variable is on top. That'll be your y. Your independent variable is on the bottom. So it's kind of like the idea of change in y over change of x, the d delta, which is that change, over that delta r, which is, again, the change. And that's going to be equal to, well, 2 times 2 is 4, so this will be 4 pi, and then decrease 2 by my power 2 by 1, and I'll just get r, plus, and then 16 pi r, so I'd be left with 16 pi. Please be careful with pi. I know it's a symbol. You have to treat it as a number. So if I want to take the derivative of pi, which is 3.14, 3.14, etc., is a number, and the derivative of any number is equal to 0. So be really careful with pi, and also be very careful with e. Number 6. Number 6 has my independent variable in my dependent variable in parentheses. So it's just asking me to take the derivative of whatever's in the parentheses with respect to the independent variable, which is, in this case, r. And so I'm going to go ahead and take my derivative. Everything is in power rule, so I'm going to do 3 times 4, which is 12 over 3 pi, and then decrease my exponent by 1, which so makes it 2, so this is equal to 4 pi r squared. Number 7, first I need to fix it. I need to go ahead and multiply. So I have a of n is equal to 3 times 5, so this will be 15n squared minus 3n plus 35n minus 7, and that would be equal to 15n squared plus 33n minus 7. Now everything is in power form with individual terms, no other multiplication. I can finally take the derivative. So that will give me 30n plus 33. Alright, f of x, I have two things I need to change. I need to change this into power form and then multiply it through. So first I'm going to change it to power form. So this will be 2x to the 1/2. And then I'm going to finally multiply it. And so I'm going to do 2 times x, and I have x to the 1 times x to the 1/2. So if I add my two exponents, this will be 3/2 plus 4 times 2 is 8. And this will be 8 to x to the 1/2. And so now I can take my derivative. And so I'm going to have 2 times 3 over 2. Well, that will give me 3. And then subtract 1 will give me 1/2. Plus half of 8 is 4. X to the negative 1/2. Notice that my denominator only has one variable. If that's true, then I can split that up. And so what I mean by that is I'm going to go ahead and change this into power form. So I have x dx, and this will be x squared plus 3. If I was going to change the denominator to power form, this will be x to the 1/3. Well, I could just split this guy up because the same denominator occurs. It's not like I have x to the 1/3 plus something else. I just have just x to the 1/3. And so that would be equal to d dx of x squared over x to the 1/3 plus 3 over x to the 1/3, which is equal to d dx of, okay, so I can simplify these two. So I would just subtract my two exponents. So 2 minus 1/3, well, that's 6/3 minus 1/3, which would give me 5/3, plus, and then I just move my exponent to the top, so this will be negative 1/3. And that would be equal to 5/3 x to the 2/3 minus x to the negative 4/3. And so I know I went through these quickly. I try to show you several examples on how to work with derivative rules. We're going to be practicing these a lot, and you'll become very familiar with them.